Who's going to be my reader? Ava, can you be my reader?
A function f from a set A to a set B is a relation that assigns to each element x, and the set A exactly one element y in the set B.
1.
The set A is the domain, or set of the inputs of the function f, and the set B contains the range, or set of outputs.
All right, fantastic. So, a function is when we go from an output, or from an input, to one output. So this 1 goes to 9, 2 goes to 13, 4 goes to 15, 3 goes to 15. That's actually allowed for a function. This is the way I think about it. I got a juicer. I take an orange. I put it in the juicer. What do I get? Orange juice. I take an orange. I put it in the juicer. What do I get? Orange. I take an orange. I put it in the juicer and I get apple juice. Does that happen?
Yes, regularly actually.
No, it doesn't happen. That is not a function. That's not a function. All right? So, I have to go from one input to one output. For instance, if I went and I drew another line from 4 to 13, can 4 go to 13 and 15 in a function? No. 4 is a cheater. Ways to represent a function this year. We're going to be talking nerdy to each other. That's called verbally. Numerically, guess what that deals with? Numbers. Graphically, we deal with graphs that we've been doing. What is a graph again? A set of solutions. All right. Algebraically, also called analytically. So this first one, the input value x is the number of representatives from a state, and the number of output y is the senators. Is that a function? No, it's not a function. All right. There's many representatives from a state, but it doesn't mean the senators. All right. This next one, this 2 goes to 11. This 2 goes to 10. This 3 goes to 8. This 4 goes to 5. This 5 goes to 1. Is that a function? No. Why not? The 2's cheap. C. Is this a function? Yes. Why yes? Why yes? You guys want to say something. It passes the what? The vertical line test. All right? It passes the vertical line test, so it's a function. Okay? We've been dealing with that for a long time. But what if I did something like this? Would that be a function now? No. Who's the cheater? 1. 1 cheated. All right? Does that make sense? All right. This one. Which represents y as a function of x? And what that means is which one is a true function? All right? And I'll give you the cheat codes afterwards. All right? So this one, I have x squared plus y is equal to 1. Let's solve for y. How do I solve for y? I subtract x squared. So then I get y is equal to negative x squared plus 1. If I put a single input, my x's are my inputs. If I put something into x, will I get a single thing that pops out? Will I get the same number? If I put in 2, will I get 2? Or, well, this one has actually like negative 3. If I put in 2, will I get negative 3? Every time I put in 2, will I get negative 3? Yes. Okay? So this is a function of x. Now, let's look at part B, and I think it might clear up here. Let's solve for y. What do I need to do to solve for y here? I need to add x. So now I got y squared is equal to x plus 1, right? Then what do I need to do to solve for y? I square root it. So when I square root it, what happens? What do I need to do if I square root something? a plus or minus square root x plus 1. So if I put something in for x, how many outputs will I have? I will have 2. I will have a positive and a negative. So is that a function? That is not a function. All right? So that is a big fat no. Here's a trick, guys. All right? You know how I gave you cheat codes on like origin symmetry and stuff like that? Here's the trick. If y is an even power, it's not a function. It's a good little nugget. If y is an even power, it is not a function. All right? It will not pass the vertical line test if y is an even power. So if I had a power of 4, 6, 8, would it be a function for y? But could I have that for a function if it's an x squared or an x to the 8th or something like that? Would that still be a function? Sure would. All right? I always like to give credit where credit's due. We can thank Leonhard Euler. All right? We can thank Leonhard Euler for giving us function notation. All right? So, Leonhard Euler, the Swiss mathematician, all right, that spent lots of time on actually developing function notation. Because before, you had an x and a y. All right? But Leonhard Euler gave us f of x instead of y. And it's more descriptive. Thank you, Leonhard Euler. Isn't he beautiful? He's cute, isn't he? Max is like, I got him. All right. So, it's actually more descriptive because it actually gives us where our x value is to then get to what we normally call our y value. In this case, our f of x value. All right. So, Leonhard, here we go. This is my function. G of x is equal to negative x squared plus 4x plus 1. And I need to find each function value. So the first thing I'm going to find is g of 2. So all I'm going to do is take 2 and substitute it in for what? X. So now I have negative 2 squared plus 4 times 2 plus 1. Now, I guess I should do this for my online folk as well. What's negative 2 squared and what's the quantity of negative 2 squared? Those are very different, by the way. All right? Negative 2 squared is what? Negative 4. Quantity of negative 2 squared is actually 4. All right? Parentheses matter. What's really happening in this top one is negative 1 times 2 squared. That's really what's happening on it. And by order of operations, please excuse my dear Aunt Sally, I don't have one. All right? Order of operations says you need to do your exponent before you do your multiplication. So that's why that's a negative 4. So when we do it on this example, then I'd end up with negative 2 squared is really what? Negative 4 plus 8 plus 1. So g of 2 is actually going to be equal to 5. Pretty good in the hood? All right, part B. Now I need to find g of t. So if I do g of t, all I do is substitute in t for what? X. So now I have negative t squared plus 4t plus 1. Now, t is not my favorite variable. However, it is used all the time. Okay, you're not going to get away from it because it usually represents a time value. Okay, or a fourth dimension in that case. All right, part C. So now I have g of x plus 2. So now I'm going to take the quantity x plus 2 and substitute it in for x. So now I have negative quantity x plus 2 squared plus 4 times x plus 2 plus 1. Guess what we get to do here? FOIL. We get to F it up. So now I end up having a negative chilling out front. And what is x plus 2 foiled? X squared plus 4x plus 4. You cannot distribute this. You can't distribute that squared. That is a big no-no in math. You will get struck by lightning. That will be a sad day. All right, the quantity of x plus 2 squared is actually x plus 2 times x plus 2. All right, so you do first, outer, inner, last. All right, and hopefully you guys are accustomed to that. All right, let's keep going. So now we're going to distribute this 4. So then I end up with plus 4x plus 8, and then I still have plus 1 chilling. All right, now I need to distribute this negative. When I distribute a negative, I like to call it Star Fox. Does anybody ever play Star Fox? Ever? Nobody play video game? Choo, choo, choo. All right, so anyway. So I like to Star Fox. It goes choo, 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 choo. Okay, whatever's negative is now positive. Whatever's positive is now negative. So you distribute the negative. Combine like terms. Anybody got an x squared? No, so he just drops like it's hot. So I have negative x squared. Any x's? Negative 4x and 4x. What happens to those guys? They cancel. That's nice. I love it when things cancel. And then negative 4, 8, 1. What do we get there? Plus 5. So g of x plus 2 is actually negative x squared plus 5 in this case. Here's our first look at a piecewise function in this class. All right. Hopefully we'll get to more piecewise function as our years go on. But why is it called a piecewise function? Because it's made up of pieces of an equation. And they actually have domain restrictions on it. So this is when it is what? Less than 0. This is when it's greater than or equal to 0. So when I need to just evaluate, I need to evaluate at negative 1, 0, and 1. I need to figure out what part of the function I'm using. So if I do f of negative 1, am I using this top one or this bottom one? Which one has negative 1 in its domain? The top one. So I need to use this equation. All right. So I now have negative 1 squared plus 1, which is 2. Okay. All right, and then I need to find f of 0. All right. So which one do I need to use, the top one or the bottom one? Which one goes into the domain of 0? The bottom one. So now I need to use this equation for f of 0. So now I have 0 minus 1, which is negative 1. And then I need to find f of 1. So which one do I use, the top equation or the bottom one? The bottom one. So now I have 1 minus 1, which is 0. All right. There we go. Does everybody understand every other odd? You start with 19, then what's your next one? 23. Then what's your next one?
27.
Okay, all right.